Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. Okay, continue on the last part of the first chapter, which is the system classification, in which there are four types of system, which are the memory or memoryless, time invariant or time varying, causal or non-causal, and linear or non-linear system. Okay, the slide shows different types of system in which we have seen some of the application or operation in the first few topics. Okay, a system can be defined mathematically as a transformation or a process. Okay, and also known as operator that maps an input sequence into an output sequence. Okay, so it applies both in continuous time t domain and also the discrete time system. Okay, if you have an input signal as xt, the signal being transmitted into a system, so the signal being processed or transformed, the t, capital T, represent the transformation. So then the output is generated. Okay, same goes to the discrete time system. Okay, let's start with the first system classification, which is the causal or non-causal system. A system is said to be causal when the output of the system at any time depends only on the input when the t is less or equal to t0. T0 means the current state. Okay, and it does not depend on the input for t larger than the current state t0. Okay, and causal system also known when the output exists after an input was applied to the system. So obviously, when you have an input, for example xt, to a system, and then your output is generated. So how come the output is generated without the input? Okay, the system is said to be causal when there's two conditions, which are when you have the past states, when you have the current state, but there's no future at all in causal system. So what are the causal states? So to determine whether the system is causal or not, you need to identify few components inside the equation. Okay, so now assume the current state is given as t0. Okay, assume the current state is t0. So your current state here, assume t0 equal to 0. Okay, so this is your t0. So this is your current state. Okay, what is the past state or the previous state when your t0 is less than 0? When your t0, your t is less than 0. This is the current state. So the past or the previous state happen when t less than 0. So any values of t that less than 0 represent the past state or the previous state. And when t is larger than the current state, in this case 0, so you have the future state. So now the t is larger than your t0. Okay, so 2, 3, and so on. Okay, let's look at a few examples how to identify whether the system is causal or non-causal based on the given equation. So let's look at the first example. given by yt equal to xt minus 1. So in order to identify or determine the causality of the system, so you need to consider at least three t values. Okay, so the first one, negative values, and then current state 0, and then the future state maybe any positive values. Alright, so let's try with when t equal to minus 1. Okay, this is in the past. So what happened to your y? Y minus 1 equal to x minus 1 minus x minus 1 minus 1. So in this case, you get y minus 1 equal to x minus 1 minus x minus 2. Okay, so when you compare the states, so the output having -1 state, so this is your current state. So your input point also having -1, so it's the same state. And then you have -2, which is smaller than -1. So in this case, you have the first one is the current state, and then you have also the previous state. Okay, so let's try when t equal to 0. When t equal to 0, so your y0 equal to x0 minus x0 minus 1, you got minus 1. So let's compare the states. So you have the current state is 0, so you have 0 and 0. So it's current state plus -1, previous state. Okay, let's try one positive values of t. So when you have t equal to 1, so you have y1 equal to x1 minus x1 minus 1, you get 0. Okay, let's compare the states. Okay, so you have the 1 is the current state. So you have current state plus 0 is still lower than 1, so it's previous state. Okay, so when you have current combinations of current and previous state, so the system is causal because there's no future state. Okay, let's look at next example. So yt equal to x2t. So again, let's try three different t values. So start with t equal to -1. So what happened to your y? Y -1 equal to x 2 times -1. So it's equal to x minus 2. Then compare the states. So the current state is -1. So you have here is -2. So this is the previous state. Okay. Next, try with t equal to 0. So you get y0 equal to x0. Okay. So you have current state 0 and 0. So in this case, you have only current state. Okay, let's try t positive values. y1 equal to x 2 times 1, you get 2. So here, look at the states. The current state of the system is 1, but in the output point you have 2. So this is future state. Okay, how come the output being developed earlier than the input being applied? So you have future state here. So when you have, in any case, if you have future state in the equation, so automatically the system is non-causal. Okay. Okay, let's look at the third example. So given by this equation, So again, you need to check for different n values in this case. Okay, you have the discrete time system. So let's look at the first n value, negative values, -1. So replace all n with -1. So this is the current state. So x -1, -1 become -2. Here is -2. So -3. Okay. So let's look at the state. So here you have the current state. Okay, so this is the current state. Then you have the previous state. -2 is previous state, and -3 also previous state. Okay, look at the second n values when n equal to 0. Okay, so this is the current state. Okay, so here you got 0, here is -1, here is -2. So this is the current state. So this is the current state 0. So this is the current state, and here you have previous state, and here also previous state. So look at the third one. When n positive values, in this case n equal to 1, so the current state is 1. Okay, here you get 0, and here you get -1. So obviously here is current state plus previous state. So in this case, there's no future values, so your system is causal. Okay, look at another example given by this equation in continuous time system. So again, try different t values when t equal to -1. So here is the current state -1. So your equation also -1. So you got only current state. Try t equal to 0. The current state is 0. So you have also the input state t0. So the system also in current state. Okay. So next, when t equal to 1, so this is the current state of the output, and the input also at the same t values. So this is current state. Okay, again, when there's no future values, so the system is again causal. Okay. Okay, let's look at one more example given by this equation. So try 3 different t values when t equal to -1. So your y -1 equal to x -1 plus 2x 3 minus -1. So this is equal to x minus 1 plus 2x 3 plus 1 equal to 4. Okay, let's check the states. So the current state is -1. So you have current state plus the current state is -1, but here you have 4. So it is the future values. Okay, let's try t equal to 0, y0 equal to x0 plus 2x. 3 minus 0 is 3. Okay, so let's check the states. So the current state is 0, so here you have current state plus 3, again another future values. Okay, so let's try the third t equal to 1. So y1 equal to x1 plus 2x 3 minus 1. So here you get current state is 1. So you have 3 minus 1 is 2. So you have future values. So current plus future. So again, let's check the overall system classification. So you notice that there's future values in the equation. So automatically the system is non-causal. Okay, I hope that you have made yourself clear with those examples. Okay, in summary, the system is said to be causal when you have the equation consists of past states, current state, or combination of past plus current state. But the causal system cannot have future values at all, only past state and current state. And for non-causal system, when you have any future values, either it is past plus previous or past plus future or current plus future, so the system is non-causal. And when it involves all states, so since there's future values in the equation, so automatically it is non-causal system. Okay, thank you.